So this video is going to be about so-called mass problems, which basically mean, we're going from the mass of one thing to the mass of another thing. And the problem is, to do stoichiometry, we need to do moles, right? So we have mass, then we're going to moles, and then we're going back to mass. That's the key thing that we're doing here. So I have 25 grams of potassium chlorate, which is this guy, right? So I have 25 grams of KClO3, and I'm going to convert that to moles. So how do I convert mass here to moles? I'm going to divide by molar mass. So I'm dividing by the molar mass of KClO3, which happens to be 122.55. So I'm doing 25 divided by 122.55 is equal to 0.204 moles of KClO3. Now I know that 2 moles of KClO3 give me 2 moles of KCl. So 0.204 moles of KClO3 give me the same number of moles of KCl. Right? And now that I've gone to the moles, I've done my stoichiometry in the mole step. I'm going back to mass. So I need my mass of KCl, which is 74. So again, I have moles here. I multiply by molar mass to give me the mass. So molar mass of KCl is 74.55. So I do this times 74.55. 0.204 times 74.55, which is 15.208 grams. This is my mass of potassium chloride if potassium chloride decomposes. So we'll do one more question. 50 grams of nitrogen. So 50 grams of nitrogen. So again, I'm given mass, I need to get to moles. So number of moles equals mass divided by molar mass. Molar mass of nitrogen is 28.02, so 50 divided by 28.02 is 1.7844 moles of nitrogen. I'm going to convert that to moles of hydrogen by multiplying by 3, because 1 mole of nitrogen is 3 moles of hydrogen, right? So this times 3 is 5.35 moles of hydrogen. And then I go to mass of hydrogen by doing the mass equals number of moles times molar mass. Molar mass of hydrogen is 2.02. So 5.35 times 2.02 is 10.81 grams of hydrogen. How many grams of ammonia are produced? So it's essentially the same thing. I go from 50 grams of nitrogen. The first step is the same, 1.7844 moles of nitrogen. But then here, instead of going to moles of hydrogen, I want to go to moles of ammonia. So I do 1.7844 times ammonia is, so there's 1 mole of nitrogen produces 2 moles of ammonia, so I'm times by 2. So 1.7844 moles of nitrogen times 2 is 3.5688 moles of ammonia. And again, I times that by number of mole mass equals number of moles times molar mass. So I multiply this by molar mass of ammonia, which is 17.04, to give me 60.81 grams of ammonia. So hopefully you're seeing the pattern now. We go from mass to moles by doing this formula, moles to moles by doing stoichiometry here, and then moles back to mass by the same formula rearranged. So there's the last question. Since this is a short video, we might as well get this covered. How many grams of silver chloride are produced? 5 grams of silver nitrate react. So 5 grams of AgNO3. First go from mass to mole. So what is molar mass of AgNO3. 169.87. So 5 divided by 169.87 is 0.0294 moles of AgNO3. Now I do a stoichiometry. So 2 moles produce 2 moles. So that's, I just times that by 1. It doesn't, the value doesn't change, so the value won't change here either. And then to go from moles to mass, I do mass equals number of moles times molar mass. So I multiply this value by the molar mass of AgCl, which is 143.32, which, so this times 143.32 gives me 4.218 grams of AgCl. And again, same question, how much barium chloride. So the first step is the same. I do mass of AgNO3 divided by molar mass of AgNO3 to give moles of AgNO3. Here I do have to do a conversion because 2 moles of AgNO3 reacts with 1 mole of barium chloride. So this conversion is times a half, or times 0.5. So I also have to times this number by 0.5. 0.0147 moles barium chloride now. Now I have to again multiply by molar mass of barium chloride, which happens to be 208.23. Because I'm doing the same formula here. Mass, which I want to find, is number of moles times molar mass. So times 208.23 is 3.061 grams barium chloride. So hopefully this is clear. Otherwise, just make sure you write this down somewhere in your note, and you can do this with different mass values because that's what's going to be on the test. If you have the general procedure down, you should be able to do it. Just make sure you know what happened from one step to another so you can repeat the calculations. All right, see everybody in class. Have a great studying session.